number 37. So let's see if I can fit it in here. So number 37 says, find an equation for a line that is tangent to the graph of f and parallel to that given line. So the graph that they give us is f of x equal to 1 over the square root of x, and the line that they give is x plus 2y equal to, oh, I'm sorry, I forgot a minus 6 there. Minus 6 equals 0. So let's transfer this equation of a line that's given algebraically from the standard form into the slope-intercept form. So that means that we get 2y, we subtract an x from both sides and add a 6 to both sides. So this gives us x plus 6. So our y is equal to, when we divide it on both sides by 1/2 x, let's see, oh, and this should be negative there. So we get negative here, and then plus 6, right? So we know that we have a y-intercept of 6 and a slope of negative 1/2. So remember that the other thing that the derivative gave us was the slope of the tangent line. So 1 over the square root of x looks like a function that looks a lot like 1 over x, but the square roots kind of modify how fast it approaches the x-axis. So we know that we get things that kind of look like this. The given line that they give us crosses at 6 and has a slope of negative 1/2. Okay? So what they're looking for is the value of the the equation of a tangent line. And remember, tangent lines are values which, if I have a point on my function, the tangent line has the same rate of change as that the function has at that point, okay? But what they are looking for is the one tangent line that is parallel to the given line. So which value of which x value, when we put it into whatever we find with the derivative, will give us a tangent line that is parallel, right? What value of x, right? So first things first, let's actually find the value of the derivative, and we'll use the limit process. So f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. Now f of x is equal to 1 over the square root of x. So f of x plus delta x is equal to 1 over the square root of x plus delta x. So let me pause this for a second. Okay, sorry about that. I had to resize my canvas there. Okay, so using these two definitions there for f of x and f of x plus delta x, we'll substitute them back in. So this is equal to the limit as delta x goes to 0 of 1 over the square root of x minus 1 over the square root of x plus delta x, and we're going to divide that by delta x. Another way that we can do this is we can write down, let me erase this, is that we can write down that this is equal to the numerator times 1 over the denominator. So we want to recognize what that is. So next thing that we'll do is let's combine these fractions together. So this is equal to the limit as delta x goes to 0 of square root of x plus delta x minus the square root of x divided by square root of x times square root of x plus delta x. And this is still times 1 over the delta x That's on the outside that I just carry down. And we do that by multiplying the top and bottom by the square root of x plus delta x in the first fraction, multiply the top and bottom by square root of x in the next fraction. Okay, so when we're done that, let's rationalize the numerator so we can see whether or not we can get rid of some quantity and have some cancellation with this factor that's out here. So we get the limit as delta x goes to 0. When we multiply the top and bottom by whatever we get when we change this sign to a positive, we'll get on the top square root of x plus delta x squared, which just becomes x plus delta x. And then we'll get minus whatever this is squared, so that's minus x. And on the bottom we'll get square root of x times square root of x plus delta x times, let's see, that'll be square root of x plus delta x plus square root of x. And that's 1 over delta x on the outside that we carry down. So this x and this minus x cancel. When we do that, after we've done that, the delta x cancels with the delta x there. So this gives us the limit as delta x goes to 0 of 1 over, and I have to remember, nope, I'm good, square root of x times the square root of x plus delta x times square root of x plus square root of x plus delta x plus the square root of x. But when I put in a delta x of 0, directly substitute that into this equation, I get that there is no division by 0, so it is a valid and legal move for me to do. So this becomes 1, hold on. Let's see. 1 over, this becomes here square root of x times the square root of x times square root of, let's see here, this is just square root of x plus the square root of x. I'm just forgetting something here. What am I forgetting? And this is that is that. Oh, I saw my problem. Little typo there. See this? I substituted these values in backwards, right? So f of x plus delta x was 1 over the square root of x plus delta x, and I substituted them in backwards. So I put f of x in the first spot, I made it positive, and I put this into the second spot. So that's incorrect. And it's just a typo. Most of the steps and the reasoning remains exactly the same. So, how does this change the situation, right? Well, let's see. Let's see if we can correct this without having to redo it all. This would become negative, and this would become positive, right? This quantity here would become positive, and this quantity here would become negative, right? And that means that this would become negative, this would become negative, because you're when you square this term here, we would get all, it would become squared, and then the negative sign would apply to both. Afterward, it would become like we switch these two, right? And this would become positive here. We would still get the cancellation there, but I would have a factor of -1 that would carry down. So everybody makes mistakes, and I recognized, hey, I had a factor of -1 right there that should have been there, but wasn't. So everybody's human, right? It's the thing that you have to catch it. Okay, so knowing that, this is equal to -1 over square root of x times square root of x, which is just this x, and then here we have 2 square root x. And that's what this derivative is equal to. So now what we have to do is figure out when the slope of our derivative, or excuse me, the slope of our tangent line, which is equal to our derivative, equals the slope of the given line, which means that the two lines will be parallel. So the slope of our given line is negative 1/2. So we have to figure out for what value of x does our derivative, which is equal to this, times x times square root of x, when is this equal to negative 1/2? For what value of x? We can solve, right? One thing that we can recognize is, hey, I have a negative 1/2 that's already in this if x was only equal to 1. So we take a guess that x is equal to 1, maybe, maybe not, right? And when we put it in, when we do our direct substitution, we see, hey, a value of x equal to 1 would indeed work. But another thing that we can do is we can try to solve by, let's see, what can we do? We can say multiply by negative 1 on both sides and by 2 on both sides, and by, well, we'll take this, we'll write it out here. 2x square root of x equal to negative 1/2. We'll multiply both sides by a negative, make things positive a little bit easier on us, equals 1/2. And now we'll multiply both sides by 2x over the square root of x, so that becomes 1 equals 1/2 times 2x square root of x. The 2's cancel here, so I get 1 equals x times the square root of x. I can square both sides, squared, so this gives us 1 equals x squared times the square root of x, which is equal to x cubed, square root of x squared. That is equal to x cubed, and x cubed equals 1 at 1 or negative 1. But negative 1 is outside the domain of our function.